Hello students, welcome back. So in this session, I'm going to be talking about clip function. So clip function, it takes three parameters, array, x1, x2. And what it does, it clips the values in this array. And that value that gets clipped, it depends on these value x1 and x2. So any value that is smaller than x1, okay, is set equal to x1. Any value that is greater than x2 is set equal to x2. And any value that is between x1 and x2, it stays the same. So generally you use clip in your sensor data. So let's say you get your data from a sensor, and sometimes the sensor data could be out of a certain range. You want to make sure that all your data is within a range. So this is one of the simple application of your uh, clip. Another one would be handling outliers or image processing, and also in finance to avoid extreme values. These are some of the simple application. So let's see a simple example. Let's say you have a data, and this is your data right here. And you know through your experience that this data should always be in the range from 20 to 150. And this is the data that you received. Clearly, you can see some of the values are not between 20 to 150, which are these ones. So what you do, you actually clip them. Okay, 14 becomes 20, right? 14 becomes 20, 15 becomes 20. The rest of the values between 20 to 150, which is right here, they remain the same. Okay, as you can see, they are exactly the same. But any value that's higher than 150, okay, they actually get clipped to 150 and they all become 150 right there. Okay, so let's see how we do that. First thing, you want to import your NumPy. So just import your NumPy, run this. All right, so far so good. Now let's take a simple example of clipping. So let's say I have these values. Okay, these are my sensor readings right here. These are my sensor readings, and 14, 15, 25, 30, 45, 40, 45, these are my sensor reading. I just wrote them a little in one line at a time so that it's easy to read, and also wrote some little notes over here. So basically, let's say this sensor, it always should return a value between 20 and 150. But you can see some values like these ones and these ones, they are not between 20 and 150. So I'm printing my sensor readings right here. Okay, I print my sensor readings. So it prints out my sensor reading right there. And then I clip them. Okay. Step three, I clip the readings and I'm specifying my x1 and x2. This is my 20, my minimum, and I'm specifying my maximum. That means my value should be between 20 and 150. When I print the output, you can see that everything is between 20 and 150 right here. Okay, these values, these two values that were lower than 20, they are not 20. And these values that are higher than 150, they are clipped to 150. Okay, let's see a little more intricate example. So let's say I know from my experience that my data should be between 40 and 140. So I want to clip these values. Okay, let's say I gather data that can be any numbers. Okay, but I know that my data should be between 40 and 140. All right. So let's generate some 250 normally distributed value. So let's generate some values, which is 250. And I want to say the mean value should be 85 and the standard deviation 25. So the way you do is using these commands, these syntax right here. So I'm creating my random dot seed for reproducibility. So this way, if I each time when I run the program, it should give me the same output. Then I'm creating my np.random.normal. I'm invoking that inbuilt method normal, and I'm creating these values, random normal values, and I'm creating approximately 250 of them. And my mean value is going to be 85, and the standard deviation is going to be 25. By the way, just on a side note, this is not going to be exactly 85, and the standard deviation is not going to be exact 25. This is going to be approximate. So the higher the number you take, the better your mean and standard deviation is going to be. Okay, so then what I do, I sort them and I convert everything into integer, and then I print my numbers before clip. So I print my numbers before clip, and then I do some clipping right here. Okay, this is where I'm doing my clipping, and I'm saying that, hey, all my random normal number, okay, this is my random normal number, they should be between 40 and 140. So I'm printing the numbers before the clip, and I'm printing the numbers after the clip right here. Okay, and then I'm sorting it out too, by the way. Not necessary, but just for visual purpose, I'm just sorting them out. So this is my numbers before 250 numbers before clipping. All right, you can see that some of these numbers are not between 40 and what is it? 40 and 140, right? So you can see these numbers are not between 40 and 140. And same thing right there. You can see these numbers are higher. So now it's going to get clipped. All those numbers, they're going to get clipped. All right, you can see the numbers have got clipped. All these numbers, they get clipped to 40. Okay, Same thing with these bottom numbers. Now let's try to visualize the KDE graph, like how does the distribution curve looks like. So let's do that. So now I'm just experimenting. I'm just basically just trying to play around, just trying to understand. So I'm importing my Seaborn as SNS. I'm importing my matplotlib.py plot as PLT just to visualize my distribution before and after clipping. So I'm plotting my data. Okay, I'm plotting my data right there. I'm using histogram plot and I'm plotting my KD equal to true. And this is my clip data. And this right here is my original data right there. Okay, and as you can see, let me decrease the size of the screen so you can see. All right. So as you can see, the this is my original data right there. Okay, and after and you can see these values, they were like below 20, right? And these values right here, they were above 140. So these values got clipped, and since they got clipped, you can see now there is a spike now over here. Okay, because all these values they came over here. Same thing over here. There's a spike over here. So if you notice, 140 was over here. There was like not as much big spike, but now because those values got clipped, there's a spike over there. All right. So there are some of the observation just want to bring it to your attention. Number one is that the left histogram, which is the original, shows a typical bell curve with the safe with the some values below 40 or above 140. We saw that, right? Some values are over here and some values are in this range. The right histogram, which is this right here, it shows how all values are forced between 40 and 140. You can see that all values are between 40 and 140, and there is a spike now. There's a sharp spike over there or at the end, and that's because these values have been clipped. Okay, I hope this session helps. Thank you.